Next question from Vishwanatha. I was wondering if you could help me to understand the process of building a pipeline using the scikit-learn pipeline module. It would be great if you could use Scalar and OneHotEncoder as part of the tutorial as well. This is a great question. So what is the point of pipeline? The point of pipeline is to chain steps together sequentially. Normally, you put pre-processing steps and model building steps in a pipeline. Now, why should you build a pipeline? There are two main reasons, and these reasons will become more clear after I go through this lesson. At least one of them will. The two reasons you use pipeline. Number one, it allows you to properly cross-validate a process rather than just a model. In other words, when you're doing cross-validation, like cross-val score, normally you just pass a model object to it. Well, there are cases when that is not going to give you good, accurate results because you're doing the pre-processing outside of the cross-validation. So pipeline, generally speaking, is useful because you can cross-validate a process that includes pre-processing as well as model building. The other reason pipeline is useful is because you can do a grid search or a randomized search of a pipeline, which allows you to do a grid search or randomized search of both tuning parameters for model and the pre-processing steps. Normally, when you use grid search, you probably think of it as, I'm going to do a search of parameters for a model. But sometimes you want to do a search of parameters for pre-processing steps in combination with the model. What I mean by that is, like, let's say I want to check different values of the C value for logistic regression, and I want to check different values of the strategy for imputing missing values. You can do a grid search that allows you to check both of those at once. Okay. Now, I've got a notebook and I'm going to try to code it in real time. If I get really behind, I'll maybe copy and paste some stuff. But this is a humongous topic. So I'm going to narrow down this topic. I am going to talk about pipeline, of course. I'm going to talk about OneHotEncoder. And I'm not going to talk about standard scalar, though I have a resource I can share on that. But I am going to talk about ColumnTransformer, because if you're using OneHotEncoder in a pipeline, you probably need to use ColumnTransformer. So I'm going to teach you that. The other thing that's really important is I'm going to be using scikit-learn 0.20. It's probably 0.20, 0.2. If you're running scikit-learn previous to 0.20, you're not going to have ColumnTransformer, and OneHotEncoder is going to work slightly differently. So you won't be able to reuse this code unless you're using at least 0.20 in scikit-learn. Okay. So with all of that being said, let me go over to my empty notebook. I am going to try to do this quickly, and it is hard to type and talk at the same time, but I will do my best. So I'm going to read in an actual data set, the Titanic data set, which I know it's overused, but it's a useful way to teach this topic. Okay. What do I have? I have a data frame, and you can follow along if you like. That is a URL you can read from. This is a data frame of 891 rows and 12 columns. Okay. So what are my columns? Well, they're all these. Let's just take a quick look at null values. So these are the columns that have null values. Most of them, there are no null values. There are a few columns with null values. Okay. I've picked out a couple columns I'm going to focus on. Like you do with any machine learning problem, you have to select features, and I'm just going to select a couple features for teaching purposes. So here is what I'm going to select. I'm going to use a loc. I'm going to use .loc, And for the moment, I'm going to say all rows, but I'll change that in a second. I'm going to select the survived column, which is our target, the P class column, the sex column, and the embarked column. Okay. If you've never heard of the Titanic dataset, you're predicting whether passengers on the Titanic survived or did not survive. So survived is the target, and then we're going to use these three features. P class is passenger class, sex is male or female, embarked is a port they embarked from. Now, everything I'm demoing gets a lot more complicated if I leave in these two rows that have null values. So I'm going to exclude any rows in which embarked is missing. Okay. And you'll see in a second what I mean. Okay. So that is my data frame. I'm going to overwrite my existing data frame with this. We're going to take df.shape. You will see I've lost two rows, 891 to 889, and I'm down to 4 columns. Here are my 4 columns. Okay. And there are now no null values. NA.sum. Let's just take a look at the head of the data frame. And here we are. And once again, let me just say, survived is our target. Passenger class, it's technically a categorical variable, but for reasons I'm not going to explain, we're treating it as a numeric variable, and that's actually the best approach. And then I've got 2 categorical variables. Okay. Now, I'm going to start by cross-validating a model that predicts survived using only P class. All right. And then I will show you how to use pipeline, as well as OneHotEncoder, as well as ColumnTransformer to, well, you'll see. Okay. So the first thing I always do is define my X. So I'm going to select all rows and only the P class column. Okay. So that's my X, and my Y is df.survived. Okay. And x.shape is 889 by 1. Y.shape is 889 by nothing. Just remember, even if you have only one feature in your X, in your training matrix, it needs to be 2-dimensional. Okay. It can't be 1-dimensional for reasons that take a while to explain, but that is on purpose. Okay. All right. Let's say I'm building a model. We're going to just start with logistic regression because this is a classification problem and I love logistic regression. From scikit-learn linear model, import logistic regression. All right. And then I tend to name my models like this, logreg equals, and we'll do logistic regression. And it's going to throw me a warning if I don't specify a solver. And I could explain why, but it's not super important. Also, you can read the documentation if you want to decide which solver to use, but this one will work just fine. They all have different limitations and strengths and weaknesses, and the scikit-learn documentation talks about it. So anyway, let's evaluate our model from sklearn.model selection, which is new, which is how they reorganized in like 0.18 maybe, because this used to be in from sklearn.crossval, I think, or cross-validation. So from sklearn.model selection, import cross-val score, and I want to cross-validate my logistic regression model using using cross-val score. So I'm passing it. Sorry, I have to stop talking for a second so I can remember what to type. Scoring equals accuracy. Okay. All right. So let me run this and we'll just talk about it for 1 second. I'm cross-validating a logistic regression model with one feature, which is passenger class, 5-fold cross-validation, checking the accuracy. The accuracy is 67.8%, the mean accuracy. So the mean of the 5 folds of cross-validation. Okay. And just, I always like to check how that compares to the, null accuracy, and the null accuracy is 61%, and the null accuracy is the accuracy you would get by predicting the most frequent class. Okay. So You're null, you want to generally beat null accuracy. You don't actually have to in all cases. And that's another complicated topic. But anyway, the point of all this so far is to quickly build my basic cross-validated model. Okay. Now, what if here is like the motivating, I don't know, motivating question, you might say. I want to add more features to my model and cross-validate it. How do I do that? The answer is pipeline, but first we have to talk about encoding the sex column and the embarked column, okay? So let's go back and show the head of the data frame, okay? For encoding categorical features, if they are unordered, usually the best approach is called dummy encoding, which is also known as one-hot encoding, okay? Scikit-learn calls it one-hot encoding. Pandas calls it dummy encoding. It's the same thing, okay? Now, we're going to do it in scikit-learn, and there's a bunch of reasons for this that I will explain at the end of this kind of lesson, all right? So if you want to use dummy encoder, here's how you do it. From scikit-learn.preprocessing, import OneHotEncoder, okay? It's a funny name, but it has a reason for it, but I'll save that for another time, okay? Then you instantiate a OneHotEncoder just like you instantiate a model. You make an instance of it, okay? Here's my OneHotEncoder. And for teaching purposes, I need to make it not sparse. I need to make it dense. Don't worry about it. You can basically, you never have to write that in the real world. So OneHotEncoder, like any scikit-learn transformer, has a fit and a transform method, and a fit transform that allows you to do both at the same time. So if I pass it a data frame column, the OneHotEncoder is going to one-hot encode the sex column. Now, let's look at these first three rows. What it has done is create a NumPy array with two columns. The first column represents, and you'll see, the first column represents female. The second column represents male. In other words, this is saying male, female, female. And you can confirm that the first three rows of the data frame, male, female, female. So this is the dummy encoding of the sex column. Now, what I'm writing right now is code you don't have to write. This is teaching code. This import and the instantiation is what you would need to do for real. Okay. So this is just teaching code, lines 20 and 21. Okay. Now, if I one-hot encode the embarked column, let's look at the categories. The three categories of embarked are C, Q, and S. As such, it creates three columns. The first column represents C, the second column represents Q, the third column represents S. So we can tell this is S, C, S are the first three rows. And you can see here, S, C, S. You can confirm that it did properly one-hot encode that data. Now, generally speaking, the way I've taught people to do dummy encoding or one-hot encoding is in pandas. I taught that because up until version 0.20 of scikit-learn, it was painful to do in scikit-learn, in my opinion. Okay, it had way too many steps. Now it's easier and it's better for a bunch of reasons that I will explain. So in the old days, what I would do is I would dummy encode in the data frame. So I would add the two. So my data frame right now is 4 columns. I would add 2 more columns for sex. I might drop one of them. We don't have to get into that. And I would add 3 columns for embarked. So my data frame would keep getting wider and wider, but I would do that in pandas. And then I would select out P class and then all of the dummied columns, as they're called. and I would select those to become my X and then pass them to cross-validation. Okay, so that's how I would do things previously. But we are instead going to do it with pipeline. Okay, so here's what we're going to do. Okay, I'm going to define my X as, if I previously, I guess previously I defined X as one feature. Okay, but now I'm going to define it as 3 features. So I'm actually going to do df.drop survived axis equals columns. Okay, and you can see that here's my X. Okay? So you'll notice that I've defined my feature matrix, capital X. It's just these 3 columns. Now, the next thing I need to show you is ColumnTransformer. Okay, and let me import it from scikit-learn.compose. Import make ColumnTransformer. Okay, and then I will start writing this. Okay, but before I do this, here is the use case for ColumnTransformer. You use ColumnTransformer anytime you have features in your data frame that need different pre-processing. Okay, what do I mean? Well, dummy encoding or OneHotEncoding is a pre-processing step. I want to apply it to embarked and sex, but I do not want to apply it to P class because we're treating that as a numeric variable, not a categorical variable. So I am going to create a ColumnTransformer that accomplishes that objective. So what I'm passing to it, I'm going to pass. Well, let me just type it, and then I will. I will explain what I'm doing. You have to get used to how it's done, but I think it'll make sense in a second. Marked, and then comma after, and then remainder equals pass through. Okay. Here is my ColumnTransformer. Okay, I make a ColumnTransformer which says I want to apply a OneHotEncoder to these 2 columns in my data frame, and the remainder of the columns I want to pass through. Okay, and let me show you what that means. So with a ColumnTransformer, we'll do a fit transform, and we'll pass it our training data, and here's what comes out. And you'll notice what we have is these 2 columns. The first 2 columns are the OneHotEncoded sex. The next 3 columns, these 3 columns, are the OneHotEncoded embarked. The final column is a pass-through of the P class column because I didn't want to encode it. Okay, so to be very clear, if I had a bunch more columns that I wanted to do other pre-processing steps to, I would have added them to the ColumnTransformer. So I could say, I want to OneHotEncode sex and embarked. I want to do a simple imputer to some other column. I want to do something else to some other column. And then the remainder you can either pass through or I think ignore. Okay, so I'm using ColumnTransformer to do my pre-processing on all of my columns at the same time without doing it in pandas. Okay, we are finally at the pipeline step. From sklearn.pipeline, import make pipeline. There's both pipeline and make pipeline, and for reasons I won't get into, I strongly prefer make pipeline, but it's functionally equivalent. So here is my pipeline. I'm going to make a pipeline of my ColumnTransformer and my logistic regression model. Okay, so remember, pipeline is for chaining steps together. So I'm creating a pipeline that does the following things. It takes my data that I pass it, it transforms the columns, which is my pre-processing steps, and then it builds my model, which is logistic regression. Okay. So it builds my model on the result. So what am I doing with all of this if you've gotten lost? I am now going to pass the entire pipeline to cross-val score. X, Y, CV equals 5, scoring equals accuracy. I guess you can't autocomplete that, dot mean. Okay. All right. There you go. Our accuracy went up to 0.77, meaning this adding these two features improved our model from previously, which was 0.67. So it went up from 0.67 to 0.77, which is great. So I want to do a few things just so you know where this lesson is going. Number one, I'm going to explain what just happened. Number two, I'm going to show you how to make predictions on new data. Number three, I'm going to show you just a quick recap of all the code in case you got lost. And then number four, I'm going to comment at a high level on why we're doing what we're doing. Okay. So those are my steps. So let's keep this moving forward. What happens when I run this line of code? This means I am cross-validating my entire pipeline. In other words, I am not cross-validating a model. I am cross-validating a pipeline of steps that include pre-processing of data and model building. In other words, cross-val score is going to do my split of data, my 5-fold split. And then after it splits the data, it will then run the pipeline. The point of cross-validation, remember, is to evaluate your model so that you can decide whether you're building a good model, and then you can use it to make predictions on new data. So let's go ahead and make up some new data to pass to the model. So I'm going to make something called xnew, and as a kind of lazy way of doing this, I'm going to sample 5 rows from X. And I know technically I shouldn't pull from training data to make my out of sample data because it's not out of sample data, but it's the fastest way to create a data frame with 5 rows. In the real world, I would be pulling out of sample data for this, but I just need some data to make predictions on. Okay. So there's my data. How normally, if you've built your model and evaluated it and you want to make predictions, what do? You do like model.fit. Well, I don't have a model. I have a pipeline that includes a model. So I do pipe.fit. And I say I'm training it on X and Y. Okay. And then I do pipe.predict xnew. Okay. So pipe.fit is like model.fit, except it runs the pre-processing as well as the model fitting. Okay. Pipe.predict is just like model.predict, except it runs the pre-processing on xnew. Think about that for a second. This is xnew. It has strings in there. So this only works because the pipeline is doing the dummy encoding of the new data, of the out of sample data, and then is making predictions. So it's actually quite amazing what it's accomplishing in that one line of code. Okay, moving on. The next thing I want to show you is a recap of what we just did. If you got lost in everything we just did, it's actually very little code. This is like all of the quote important code that we just wrote, meaning that I've eliminated the exploratory code and the teaching code. And this is going to be in the notebook that I will share with you after the webcast. Here, and I'll summarize it briefly. Here are my imports. Okay. Here's where I read in my data frame. I selected my columns. I defined my X and Y. Here I made my column transformer made up of a OneHotEncoder and passing through the remaining columns. Here's my model. Here's my pipeline. That's a column transformer and a model. Here's cross-validation of the pipeline. Here is building my xnew data frame. And here is fitting. And then here's making predictions on new data. Okay. So this is everything we just did. If you got lost, this is like the workflow. All right. I'm going to leave that up on screen while I kind of comment on this for the next couple minutes. What we just did is we used OneHotEncoder, ColumnTransformer, and pipeline. Here's the question. Why would we not use get dummies instead? Because we could have used pandas get dummies, appended those to the data frame, and then defined X based on the pandas data frame. That's what I used to teach, as I was saying. But why is the approach that I just showed you better? It is better in 4 important ways. Okay. Number 1, you don't have to create a gigantic data frame. You'll notice that OneHotEncoder does not affect our data frame. So our data frame stays 3 or 4 columns, and that's it. And that's easier to explore and easier to manage. Number 2, when new data comes in, you don't have to use get dummies on it, right? Because if you are using get dummies on all of your training data, then when out of sample data comes in, you still have to use get dummies on it. Plus, you're going to have problems if your out of sample data has different categories than your in sample data. Like, let's say our in sample data had C, Q, and S, but our out of sample data only had C and Q. Well, it's not going to produce the correctly shaped data frame. This is going to cause problems. All right, number 3 as to why this process with scikit-learn is better. You can do a grid search, as I was mentioning, with both model parameters and pre-processing parameters. And then finally, reason number 4, in some cases, pre-processing outside of scikit-learn can make cross-validation scores less reliable, okay? And this gets complicated, but basically, if you're using a standard scalar, if you're doing missing value imputation, if you're using text data, and a variety of other circumstances, if you do your pre-processing before scikit-learn, your cross-validation scores are possibly going to be unreliable. Okay. So those are 4 huge reasons why you should, ultimately use the process I've laid out rather than get dummies and pandas. Hope this video was helpful to you. If you'd like to join my monthly webcasts and ask your own question, sign up for my membership program at the $5 level by going to patreon.com/dataschool. There's a link in the description below, or you can click the box on your screen. Thank you so much for watching, and I'll see you again soon.